Addiction is a progressive disease that causes many different kinds of problems within the body of the person abusing substances. The nature of the problems and how serious and long-lasting they are depends on the substance used, what is in the drug, the extent and amount used, and the person's individual physical makeup. Because the central nervous system, which is made up of the brain, the spinal cord, and the billions of nerve cells that extend throughout the body, is responsible for controlling all behaviors and functions, much of the research about the effects of addiction has been focused there. Substance abuse has been found to affect the brain, the main organ in the central nervous system, in two key ways. The first is that chronic substance abuse disrupts the brain's reward system, which is responsible for shaping human behavior. The brain is made up of a vast network of specialized nerve cells called neurons. There are about 100 billion neurons in the average human brain. Neurons communicate with each other by sending chemical signals, known as neurotransmitters, to one another. Each neuron is separated by a microscopic space known as the synaptic gap. When activated, a neuron will release neurotransmitters, which exits the cell and are received by adjoining cells when they land into the appropriate receptor sites. The neurotransmitters will eventually be released and taken back into the cell it originated from. Different neurotransmitters have different shapes and correspondingly different shaped receptor sites. Once the neurotransmitter has found the proper receptor, it triggers the receiving cell to release the same type of neurotransmitter to adjoining cells. This vast and complex system controls everything that is happening within our bodies. What we perceive through our senses, how our body functions, our thoughts, memories, and feelings are all a result of these continuous processes. The main neurotransmitter affected by substance use is dopamine. This powerful molecule is primarily responsible for the feelings of pleasure we experience when we engage in satisfying activities such as eating, seeing something beautiful, or sex. When we engage in anything satisfying, the brain releases dopamine into the synaptic gap, which triggers adjoining cells to release their own dopamine molecules. This causes a cascade effect which floods the brain with these pleasure-causing chemicals. Different activities or ingesting different substances will cause the brain to release differing amounts of dopamine. The more dopamine that is released, the better the person feels and the more likely they are to repeat this action. This is nature's way to shape our behavior and motivate us to act in ways that make us feel better, which usually helps us survive and thrive. Under normal circumstances, activities such as eating, being caressed, or having fun causes a release of dopamine, making it more likely we will repeat that behavior. However, chronic use of substances disrupts the reward system and causes the brain to cease releasing dopamine when engaging in these everyday activities. This occurs partly because drugs stimulate the release of dopamine in greater quantities than ever before experienced. Drugs like alcohol, heroin, and other opiates stimulate the release of large amounts of dopamine. Drugs such as cocaine, methamphetamine, and nicotine, which are stimulants, increase dopamine levels by triggering its release and also by blocking the receptor and reuptake sites of the neurons, forcing dopamine to stay active by keeping it in between cells. Either way, the user experiences intense feelings of happiness and well-being due to abnormally high levels of dopamine. Because this euphoria is unlike anything the user has previously felt, they are driven to repeat the experience over and over again. Eventually, the user's reward system becomes desensitized and no longer releases dopamine for everyday activities, such as eating or being caressed, and will only respond to events that cause very large releases of dopamine, such as the use of drugs or alcohol. Once this happens, the user's brain begins to change and addiction starts taking control. Eventually, the reward system will stop responding to the drug. The user will then have to either increase the dosage in order to experience pleasure again, or switch to stronger drugs that released more dopamine. Coincidentally, this is commonly known as chasing the dragon. Hardcore addicts will eventually stop feeling any pleasure from using, but cannot quit because of the very painful and difficult withdrawal symptoms they experience when trying. This can include severe abdominal cramps, shaking, seizures, and pain levels equal to bones breaking or being severely burnt, all accompanied by debilitating depression, profound emotional distress, and extreme flu-like symptoms. Unfortunately, the changes in the brain do not end there. The second key change which occurs in the brain is that repeated behaviors, their associated feelings and thoughts, cause the brain to create a new neural pathways. These are channels or paths within the brain that neural signals build up as they get used over and over again. The more these pathways get built up, the more the brain tends to use them as they become the easiest, most efficient paths neural signals can take. As addiction progresses, the user will form more and more associations with using, which expands and deepens these networks. The bigger these neural pathways become, the harder it is for the user to change their behavior and reactions because their brain is driving them to behave in a way it's become accustomed to. It can be illustrated like this. When a person first starts using drugs or alcohol, they may only have a mild association between using and feeling pleasure, because they still have many other activities and things that create pleasure and few experiences of needing substance to feel good. However, as they begin to use substances more frequently, their association between using and pleasure deepens. At first, they thought that drinking once a month was acceptable, so the neural pathways were not very prominent. However, because repeated behaviors cause the neural pathways to become stronger, each time a person uses, the pathway deepens. If the person starts drinking once or twice a week rather than once a month, the neural pathway grows accordingly. Frequency of use, however, is not the only factor that builds up these neural highways. Occasions, circumstances, and feelings do the same thing. As a person begins to associate various events with opportunities to use, the neural pathways build up. The same is true as a person accumulates experiences of using substances to cope with feelings. Relief from emotional distress forms some of the most powerful associations in the human brain because we find emotional turmoil hard to endure. After years of reinforcing these pathways, the brain finds it very difficult to take any other path. At this point, their using lifestyle has caused their brain to become hardwired in this specific way. This accounts for the enormous difficulties in attempting to overcome a serious addiction. Basically, the addict's brain is working against them. That is why recovery from addiction has to deal with behavior, thoughts, and feelings. A person who believes that all they need to do is just quit using is basically deconstructing only part of the neural pathway. By doing so, they are failing to deal with the pathways that were created by their thinking patterns and by using substances to cope with their feelings. A person who adopts a comprehensive approach to recovery and is actively working at dismantling the whole neural network is much more likely to succeed at overcoming their addiction. As the user in recovery forms new thought patterns, finds healthier and more appropriate ways to cope with their feelings, and accumulates more and more experiences of not using substances, they are in essence deconstructing old neural pathways and creating new ones, which is effectively rewiring their brains. Eventually, after several years, the brain returns to a more normal way of functioning. New pathways are built, supporting healthy behavior, and the brain's reward system resets itself and starts responding once again to everyday stimuli.